Welcome everyone. This is the number 3 meetup. It's gonna start in like a few seconds. Test the buffer and all of that. This is the third meetup. It has been fun so far. So we think we're gonna continue to do it once a month. The internet password is there. Bathrooms are outside on the left. And anything you need, just ask. So this time we're going to talk about concurrency, and the first thing we're going to talk it's a basic lesson. It's nothing too high, but still there are some nice tricks to learn. Now I see new faces, so I'm gonna go and review what we did last time, what we did in part 1. This was more for the guys that did the last time, but I think it's gonna be helpful also for you guys. So we reviewed the very basic libraries for accessing a file and byte stream and strings. So we went to see the basic interface, reader and writer, the composite reader and writer, some example. I'm going fast because this is not the real presentation. How to open a file, how to read the contents, and read and write. Some utilities like utilities card when you want to read and keep just throw away what you're receiving from your input. Utilities from the OS, expand the environment, how to get the user info, pipe, start process, how to access clean, globe, and walk. This bet that you remember because we might use it in the exercise of today. How to check if a path exists. How to create a stream, an in-memory stream, peek, read byte, and read byte. All the basic utility and building blocks of how to manipulate string. Particularly, we emphasize the use of defer, so in case you don't use, and just as recap, defer is that keyword that allow you to run a function inside a function when the function completes its cycle. Like when the function will run only when the function is shut down, complete. Some example of gotchas. When like buffer always need to be flushed, otherwise you might have incomplete streams. An example of using of compression, the gzip library, and the binary library that allow us in particular to serialize and deserialize entire structures. Okay, and this was last time. Now this time we are gonna go function literals, go routine, and channels. Select an encoding gob. I think we are not gonna able to do it. So function literals. Function are first-class citizen in Go, so you can manipulate them as a type. You can create a new type called callback. That's its type is a function that doesn't take any arguments and doesn't return any value. So you can create a variable my function and simply assign it from the code. Now here we are creating a new function literal, just in line, and at this point we can call it as any normal function. You see, this is what we expected, right?
This is the lambda expression for
Of Go, exactly. Now the nice thing is like you can use the scope of the outer function inside the inner function. Okay, so we can do something like we create an array of 10 functions. For 10 times we create a function that prints the value. We save the function inside our array, and then we iterate over each function. Here is like the pointer to the function, and then we call it to actually execute.
This is called a closure.
Mm-hmm.
When you use something from outside the scope of the function.
But what happened here? Is that what we expected from the closure or from the function literal?
It's not what we wanted.
Because we are iterating over from 1 to 10, print %di. Okay, so you see what happened here. Like it didn't save the value when the function was created. It only saved the reference to the variable. So when it went out of this loop, the reference to this variable was 10 because it was the last value. Okay, and that's why it's printing all the time.
And note that there's a new I on the next 4, but it's a different I because it has different scope.
So Mickey makes a very good point, and it's like this assignment operator is valid only for this scope. Once it gets out, yes, this is referencing this variable, but the name doesn't really matter to them because it's referencing a pointer inside the memory.
And colon equals always declares a variable, so if it had been in the same scope, it would cause a compiler error.
Whoa. We can, if you don't believe us, we can.
That's shadowing what we're doing right now.
Yeah.
Yeah, this we are shadowing, but then we can do this again, right?
Yeah, and shadowing is a very hard to detect bugs.
So what it's doing, this is like this I is creating a new variable inside the same scope that is hiding this one external.
Can you try I colon equals I? That'll probably fix the function.
What is it?
Right there, do I colon equals I. Right where you were before.
Already the I equals 0?
Right, you had I colon equals 0, do I colon equals 1.
I.
Or, you're right, I colon equals I.
Like this?
Yeah. Gonna try running it.
Ah, that's interesting.
Yeah.
Because you're making a new variable. Each time it runs, it's creating a new variable I and assigning the variable I from the upper scope, which, you know, causes it to work. Different number for each time.
Okay. Now maybe we want to
Wait, you said
factor.
that's interesting. What the way you're gonna head to as the solution? If not that, or you're gonna use bit of AL names?
This is another solution that I didn't think about, and I'll just learn. That's why I like the meetups. And but another solution is creating a function factory, right?
Mm-hmm.
Like I have a function that returns a function. So when I pass the value, this will bind to this new variable and return it, and so it will return the same value.
High order functions to the rescue.
Yeah. Here is one of the mantra of Go. Now, concurrency is do not communicate by sharing memory, but instead share memory by communicating. And really, it was supposed to comment this, but it didn't work, as you guys see. Now, the function literal was just a tool so we can use it forward. But just you, and there are other tricks you guys want to add to the function literals. Now that comes to my mind straight. So let's talk about the Go routines. That's, I think, one of the main point of Go. So we say that the Go routines is a thread of logic, but it's not a thread in the operative system sense. It's just in the logical sense, and it's lightweight, and use as much stack space as really requires. Doesn't allocate upfront memory. So to launch a Go routine, we just have to use the special word Go. Okay, now you know why the language is called that. So Go and simple the invocation of the function. For example, we have the main function, and then simple status, and then we just invoke it, right? So, and this, what we expect from this, it just will print, it works, right? What? So this is like a brief parenthesis. There is this talk that is hilarious about programming languages and things that you don't expect out of it. So
it's mostly JavaScript and Ruby, right?
Yeah. Yeah. So, but I think when I first ran my first Go was like, what? So what happened here? What happens is that What happened is that the Go routines, all the Go routines are terminated when the main Go routine exits, and the Go statement is released immediately. Like the function gets invoked and everything, but it returns immediately. So what happens previously is like it will launch the Go routine status, but will not execute it. The main Go routine still had the command, and it will terminate the entire stack. So one silly way to fix it is just...
That won't fix it though.
Yeah.
Replace for with select. Now it'll work.
Why wouldn't doing the for loop fix it?
Okay, the issue with using a continuous for loop is that it will stop anything else from running. Go routines have to yield to the scheduler so that another Go routine can run, and right now Go max prox is by default set to 1.
Well, what if we set the invariant variable to make it run two threads at the same time?
If you said that it could use 2 threads at the same time, then you would have, you know, the main one thread being taken up by main, and the other thread would actually run status.
So it would work.
Right, it would work, sort of. But I just recommend never using a type
infinite loops.
Yeah, infinite loops are bad.
Unless you're writing Haskell code.
All right, so we need a way of like waiting that all the Go routines complete. But the main point that I want to follow now is like these Go routines are very fast, are very lightweight, and specifically they are not threads. Okay, like you can think that there are like the process, the threads, and then there are like a series of Go routines that they signal, hey, I'm ready, I have to wait, or I'm ready to be completed, to be executed again. And we can also say you can have 1,000 Go routines running in one thread. Okay.
And I have a program where when it's busy, then it starts thousands of Go routines a second. and it's fine. And it seemed when I saw it first, I thought this is a terrible idea. This could never, but it's fine.
And so, like, not everyone experiences itself. So they might not believe us. Say, no, that's not possible. Okay, so let me see here. So let me run this program from the command line. So this is the same program, okay? And yes, that is 500. Let me start to, where is it? We want 1,000, right?
Let's get rid of the infinite for loop, so
I'll leave it there for now.
sure, why not?
And then go run. Because the
You can put underscore.
all right. So now we are running this this program. And this program just creates 1,000 routines that each one will try to loop. But as Steven said before, like one of those will block for everyone, and we will see like more precise. What I want to show you is this. We go and we ask the out here is the name of our program that we just created, and we are asking give me pgrep will give us the PID of the process, and then top will show us like what's going on this thing. So you can see the number of thread is only 1. Okay, and what is it? The private memory also is under a megabyte, 4.6 megabyte, with 2 threads. Not bad at all. Now for comparison, we want to open. I wrote another little program that does the same thing in Python. Okay, so this will just loop, and it will create 1,000 threads. Okay. So we want to see what's, just for fun, what's the comparison. Okay, and then we ask the same thing. And like here we can see that we have 1,001 thread running already, and the memory will go up by a lot. You can hear also. It's get messy pretty heavily, and it's interesting that most of the process out there right now in production have 1,000 and more threads. Okay, so.
It's surprising that that works too.
Yeah, that works too, right? But I don't know. There is something here that we could use that extra power doing something else. Okay, so here you need the 4 machine. If you are on cloud, you have to pay 4 times the instances and all of that. And like when you have 1,000 instances outside, it starts to be quite expensive. Okay, let's close this before it starts frying my computer. All right. So one thing that I want to know here is, yeah, how you know that there are 4? Like we saw that there are 1,000 threads and only 1 thread, but how can we know if there are 1,000 Go routines? So we're going to introduce one of the first packages of tonight. That's the runtime. With runtime, we can know specifically with this function number of Go routines how many coroutines are executing right now. Okay, and this is the same program as before, just with some printf here and there. So what we will expect here is, as we loop in this main first cycle, we'll just print all this, like you will see 1, 2, 3, 4 until it gets to 1,000. Okay, but as you see, it does not do that, because as long as I think one of the first functions starts, specifically the routine number 3, it blocks everything in this for loop, and all of the rest is locked. So what we can do, one way to solve is, one is the sleep, but another way is we just want to say from inside the routine, just yield, like, okay, I'm good for now. Sharing is caring, right? And this is time, but what we share is the processor time. So there is another function inside runtime that's got sched that yields inside the routine. So adding this this line inside each of the routine, it will loop, yield, and loop again.
It will also yield automatically when you do stuff like read and send to channels, do syscalls, which means any type of I/O. Just right, invoking time in multiple ways. Just anything that would cause a pause, it'll yield to the scheduler. This is for those tight loops where you don't have any of that.
As we saw before, this one, right? This tight loop can't do much about it. So we can just add this function, and we will see what we want to expect. You know, like everyone will run and show that there are 1,002 Go routines running all the time. Now, what we want to do now is we want to wait for all these Go routines, okay? Because we want to clean up and finish normally all of the execution. We're gonna see the utilities that the package sync provide. In particular, is white group. White group has this main function that is add, done, and wait. What we want to do is we allocate the wait group, and we increment a counter for each Go routine that we execute. Okay, so this range V is for A, B, C, and D. We'll create a Go routine with Go and our function literal, and then we will the function will print, and then it will signal to the wait group that I'm done. And the wait group will wait that basically this all the function will complete. So
now, one thing some people do that is incorrect is they would put the wait group add one inside the Go routine, and since that Go routine is not likely to start until after this blocks, what ends up happening is they don't all get added before you wait. So it could be that none of them are added, and it immediately returns with none of them running.
okay, so
Does something bad happen if you call done on a wait group that's already being waited for?
No, what will happen is it will say, yeah, I'm done.
It'll
even
just
though
decrement the counter.
So what Steven is saying is the wait group add one, it can't be put inside here. Okay, like this. It can, of course, you can. See, it just exit. Why? Because it will create all the functions, but the function will not be executed. Okay, so the counter is 0, and when it gets to the wait is waiting for 0 events and just exit. Okay? So we want to add before creating the function. But why we receive DDD when we expect A, B, C, D?
Same problem as on the first one, where you're not making a copy of the string.
Correct. Everyone is notice it? Okay. So we modify the function to just take a string, and we invoke the function with the specific string. This will bind it a runtime.
The parameters are evaluated at the time you call go. So it'll take whatever the current value of s is and make a copy.
And this is what we expected out of the entire loop. Okay, any more trick with the white group? Don't think so. It's a normal object, so you can send it around. It can be a parameter. You can do anything. Well, there is nothing special about it. If you want to know how they implement it, we can go and you can check the source code. They have like a nice example also
if you
here.
click on the white group, we'll get to the source code.
Yes, you can click on the weight on the name of the type, and you will get straight to the source code. So you see, it's a structure with a mutex and a counter and the number of waiters. Semi stands for semaphore, probably. And they use other primitives from the sync package. You see, like atomic and what else I saw?
The package.
The mutex.
The package sync/atomic is used for adding and changing the value of certain types of integers and pointers atomically. So it can be run concurrently.
And it should be used only for like primitive parallel data structure usually. Like it's a very low level. Okay, so, but there is something here that a good Gopher should not do, or like should be doing, right? Because what happens is, if someone at some point says,
The parentheses won't work.
I want to do it in defer.
It'll work.
Probably not.
I'm pretty sure the syntax takes. It's just good stuff.
see deadlock. Because what happened here is like, I returned from the function before signaling that I was done. Okay, so this weight will never be decremented and will stay there up and running. So,
You will always defer and put it at the top.
yeah, so any time you just defer, and as soon as you create the group done. Easy, if you know it. There it is. Okay, the other option is to use channels. Okay, we saw briefly channels in the previous Meetup, but let's talk a little bit more about them. The way to create a channel is you use the primitive make chan, and you use here the type, and here you specify the size. So the size can be 0, 1, or more.
It's optional.
Size though is optional. Size is how much to buffer it. So if you send to a buffered channel, I'm not sure if you're going to go over buffered channels at all. Okay. So you can have a size of 0 and it will still work.
So, for example, this is we're creating a channel that is unbuffered, okay, with size 0. So as soon as you send a message to the channel, there must be someone on the other side waiting for receiving it, or it will block. Like the coroutine that's sending the channel will block until some other coroutine will pop from the channel. Okay? So this is the same coroutine, and we are sending to a channel of integer the value 1. Okay, and as you might guess, this will lock. Okay, so stack trace. There is no panic, you know. If you see the stack trace are very useful to debug, and will tell you exactly which of the coroutine is in deadlock. And as you can see, this is where it got stuck at level 10. And this second coroutine is the main coroutine that gets executed before your main. So out of curiosity, I went inside the source code and I saw how that thing works, right? Here, this is the main coroutine, the real main coroutine actually, because the one that we invoke is this one.
Notice they have a Unicode dot drives people not.
Yeah, I noticed that, but why is that? For doing some...
Because you can't have dot in the main. It's not about
Yes, you can.
in the name of a function?
Sure. You can have any Unicode letter, I think.
But the dot
I know, but
is-
you didn't
It's
have a
not
full
the
stop, so you have to have some other kind of dot.
This
yeah,
is...
this is the Unicode, this is fine, but I'm saying
This
the
is
regular-
C code,
Yeah.
so it
Yeah.
doesn't matter, yeah.
But C code doesn't support Unicode, does it?
What?
C supports GCC.
This
supports
doesn't use GCC though. This is compiled by the Plan 9 compiler.
Ah, that makes sense. Say like, what's the Plan 9 compiler for the?
What?
Plan 9 compiler, it was the previous one for Inferno, no? That is the whole story.
Inferno is based on Plan 9, I think, so Plan 9 is the original operating system.
Okay, so how we can fix the previous error? Like one way is to just launch the sending the message to the channel in another coroutine, and this it will send this. What happens is this will create the coroutine. The main coroutine blocks because it's waiting for reading from an empty channel. At that point, the other coroutine will spawn and will signal the message. Then the same thing. Now we create another channel with only one value, can buffer only one value, and what happens is, as you think, is it will send the first one, this will block and release, and this will block again, but because there is no other coroutine that's sending, the program goes in deadlock. And simply by running this, it completes.
Also, it won't know if you deadlock a single go routine, but there are other Go routines still running. So that's the most effective way to get a memory leak in Go at this point, is you start up Go routines and they never end.
Like spawning Go routines.
Spawning Go routines that send to a channel and no one's ever receiving from the channel. That would be a good way to cause a memory leak.
That sounds fun. Let's try. Okay, so package main. Let's save it. I like to spawn. For right, go function, and then what we do? We can do just make a channel, and then we just send to the channel, right?
You need to change the number.
I was seeing if you guys were paying attention. And then here, any ideas?
Make another channel. Look at it.
One idea is to, okay, that'll never run because the for loop goes forever. But you
Oh,
want
right,
to
but this-
yield. You want to yield in that for loop, or else it'll just keep spawning without those Go routines ever running.
All right. So how can we yield? Remember, use the function runtime, right?
Yes.
The runtime, and then we do go get. Boom. For who is wondering, I'm using Sublime 2 with the Go Sublime package, and I like it. It's fun to use. Now we want to run this thing.
And it means too, this with parentheses, you never notice. Like I had the parentheses and semicolons all the time, and you hit save and it cleans it up.
Oh, that's interesting. Let's see. It's,
You apparently don't have it set up right, or
oh,
I'm not sure if it
No,
goes through.
try to, it didn't remove it when you saved?
I think control format. No.
Interesting.
Yeah, maybe it's something. Anyway, let's continue. Yes, this will work, right? But I have still to log on the channel.
Yeah, now you say you blocked it.
So this will block.
Yeah.
Right.
The function will start.
But the for loop will go forever anyway.
Yeah.
I think
That's-
you get a panic, huh?
Do I get a panic? I don't know. Okay, well, this is I like to spawn, no? Let's see what happens. What do you say? So simple goal run. You guys can see that. Go defer must be function call.
Yeah, you need to close the count.
Okay. Boom. So how can we monitor this thing? And there you guys. You guys see the. Okay, we have a very efficient memory allocator, and then it will start. This, let's kill the other server. Okay. That was fun. So if you guys want to do this is one way to do it. I'm sure there are more creative ways of tackling this challenge. Let's see if you have any question online. No, doesn't seem. Oh yeah, I think so. Yep. Okay, cool. Yeah, we're gonna use a omnidirectional microphone.
One.
Next one. We're gonna put like a nice one in the middle, so it will have nice. Okay. How are we time? What time is it?
Yeah, it's 8, so you get time.
All right. What we have here? What happens if we read from a closed channel? So for you can create a channel and it's immediately open, but you can also close it. That means that the channel can not have any more communication. Now, anything that's inside the channel will remain in the channel and will, if you are reading from the channel, will consume it until it will be closed. So, if it's buffered, of course. But what we want to see is what happens if, in this case, now we are creating a channel and we are immediately closing. And then we try to read from it. We receive this 0 value that I guess is the default value of the channel. Okay. I say okay, and this is also for for any value, right? For this was a channel of integer. This is a channel of string, and it will just return empty string. So another way of reading from a channel is using this syntax over here, because we want to differentiate. Like, what if 0 is a valid value, and the channel returns a valid value? Then we have two cases where we want to differentiate when the channel is closed and when the value is valid. So there is this other syntax that you can specify if the channel is open, OK will be true. Okay. And the channel is closed because we just closed the channel immediately. But if we send a message, then the channel will have one message because it's buffered, and that will print completed with 1. Okay, so this is a good case to remind. And notice that you can test, you can assign, and then you can use the test, the Boolean value result to select your scope. Okay.
Another example with closed channels is when you do a for loop with range over a channel, it will stop when a channel is closed. So you can start up a Go routine and say for every value on the channel do something, and then after the close it will stop.
Okay, so to reinforce, let's make an example of Steven's example.
So even if you close it early, the for loop will still keep going through as long as there are values in the channel, and it will stop automatically. Okay.
So what we can do is this. Now we make a channel of 10. We iterate. Over all of them, and then we send the value inside. This has to be outside. So we fill the buffer. Because it has 10 spots, it doesn't block. When we finish, we close it, and then we want to read. For this is like this, right? Okay, and then
Not be okay, but range.
Range.
Colon equals range.
Range blocking like this, and then right there, right? For range equal range blocking.
But there's no okay, just
because this one.
right. Just printf the value.
Okay, so this will iterate over. It will consume the channel one by one until the channel is closed. And let's run this and see. Well identified character. What I'm doing wrong?
Do you know which line 10 is?
Go 10 undefined. I think maybe this one.
Oh, maybe the error, if you cut and pasted the error.
Mm-hmm.
Like maybe one of the errors, like the one just before blocking, it looks a little crooked. 2 lines up.
Oh no, it's not compiling at all.
I know. I'm wondering if it wasn't a proper the bracket. If it's a real bracket, or if it's a bracket that looks like the right bracket but isn't. No, that one's okay. It's the same, huh?
Well, let's make a new. Okay, blocking make.
And that's what's awesome about Go format.
So it's what we expected, right? While if we don't close the channel, what will happen is that. Okay.
What happened was the only Go routine, which was the main one, deadlocked because it was trying to read in from a channel that there would never be anything sent to. So so the program ended.
Wait, but you did send something to it, but it.
Well, okay. It looped 10 times, and then there was nothing else to be sent to it, but it was still waiting. Because it wasn't told that the
But it didn't.
channel was closed.
Oh, it did print something.
It did print something.
Right.
When it arrives, like it
Yeah.
finds the channel is empty, and then it sees, oh, there is no other Go routine. So it knows that.
And then if you made the first buffer 5 instead of 10, then you will block 2.
Yes.
Yes.
Would it block with a deadlock or just wait?
Deadlock.
Yeah. Very
And
good at
nothing would be printed because it never got to the print
Right.
loop.
It's very good at figuring out when there's a deadlock.
Right.
When I work with JavaScript, that's one of the things that's frustrating, is that it's very easy to basically make a deadlock and
It's
how to find it.
It is pretty much when you send or receive on a channel, it calls the scheduler, and the scheduler looks to see if there are any active any Go routines ready to be run, and since there aren't any, it panics.
Right.
All right. So another gotcha of the channel, for example, is the reference. So if you want to, let's say you have your own type. Okay, this is how you declare a type in Go, and you are creating a channel of your own type. So you want to send your own objects inside this channel. We create a reference to our new type. We set some state 100, and then we send this reference to the channel. Okay, then the same reference, we change the state. Okay, we print it and then we read from the channel. What you guys expect out of this?
The state will be 200. No, 100. No, 200.
200, who offers more?
200. Because it's the same reference, and that's the last value.
Correct. Okay. Because we are changing state on the same reference, and so this you guys have to pay attention when you create a channel like this with a reference to a type. You're sending the pointer doesn't change, no, but the reference to the pointer, it can be changed. So.
And watch out, if that was another Go routine, you would be editing memory that you had told another Go routine it was allowed to use. That could end badly.
It will not cause panic state, or it will just
it would not cause a
corrupt
panic,
the
it
memory.
would be even worse. A panic, at least you would know that something was wrong.
It was just have something that changes your variables. So how to prevent this? One way to prevent this is once you create the type and you send over the channel, you don't touch it anymore. You say anyone that says on the other side is going to be responsible of that state. Or otherwise, you create a channel that's not a reference, but is the type itself. And what this will do, it will copy over the channel the entire memory of the structure. Okay, of course, like if your structure is pretty big, that will have some consequences. But like for you guys familiar with the value object pattern of creating an object out of an object, anytime you change the state of the object, you create a new object. You can use this one, and this will run and return what we expect, like 200 in the first one that we reference, and the one that we send over the channel will return 100.
What would happen if you said instead of changing the reference state, when you're changing it to 200, you say reference equals my type bracket state 200?
I said again.
On that line you're on here.
Okay, this one.
Yeah. So say reference equals.
You want like this?
So reference without state, without
yes.
dot state.
Okay.
And then equals my type funny brackets state colon 200.
Okay.
So now it works, right? Because we just have two different references.
Yes.
Well, it already works because it's a value.
Oh right, but if you change it to be if you change it back to be a point, sending the references down the.
Correct. Yeah. No, because that reference is another one, and so I think this is what you want, right?
This is, right, and this would be less inefficient, right? Because now at least you're just putting a pointer on a channel instead of the whole block of data.
Yeah.
Right, yeah.
In this case, because it's a struct with just one integer,
You're
it
creating
should be roughly the same memory.
But if it was
yeah.
like giganomious struct.
Yes.
You basically have created a new memory. So you are saying this is like you send the reference over the channel and you forget about the reference. So
Assuming my type's a big type, but yeah, this
Right.
in this case, and it may even be smaller than a pointer.
So one thing that I want you guys to try is to create a channel of channels. Okay, because channel is a primitive, you can send a channel over a channel. And like have that in a way that then there is a routine that fetches this channel and start another Go routine with that channel attached. Okay.
I think they have somewhere a good example of a load balancer that this is a channel of channels.
That's interesting.
Because
it's a multiplexer.
when you get a request, you create a channel for the reply and a function to handle it and send them on the channel, and then our workers, every worker gets.
So there is, I saw some reference on the Golang documentation.
Oh, and if you guys haven't done so, do take the Go tour and read Effective Go. Those are the two things that are most recommended for new people.
So one is doc effective _ go. This is a whole line, and the other one is the tour. And you can get the tour from Golang / doc, and then go to tour of Go. And it's nice and interactive. It's very fun. Okay. So how can you pass around channels of channels? Channel of channels. Okay, well, let's define a type. How this will be the channel of channel. So we want a type there will be a channel that has a channel, right?
Yes.
We can just put interface here. Right? This will make sense because I'm making a channel and its type is a channel of interface. Okay, let's try. We call that yeah, that worked. So how do we send a channel over a channel? We have first to create a channel. Put some buffers so it doesn't lock. Okay, so we are sending a reference to a channel over a channel, and I think this, right?
I'm not sure what you're doing.
Because I'm reading from a channel, and then I'm reading from the channel that returns the channel. But it's a deadlock because.
Yeah.
And I have to send something on the channel.
Send it one.
You guys are following? Okay, this is just like little project just to like exercise the modeling of what's going on with these data structures. Of course, this is not clean, this is not nice, this is not, but it's fun. For the new guys, unless they already know, interface is the generic type that you can use. Anything implements interface because it says all the types that implement this set of function, and the set of function is the empty set. So pretty. Okay. Another standard lib package, and this is one of the most used usually, the times lib. This will yield the current Go routine. And pay attention, is the duration is simply an int 64. So
It's in
if you go
millisecond or microsecond?
or
in the duration, so now they have a duration,
yeah. Represent the elapsed time between two instants, and it's nanoseconds count.
Yes.
And they have this. This is a numeration, right? This is a numeration that you can say how much time you want. If you want to specify 10 seconds, you do 10 times time.second, and that will return the exact nanosecond value for that value.
And these are of type duration, and all the ones in the const, although only the first one says duration, because they are all grouped together, they are all durations.
In this const.
Right.
So all these constant variables are of type duration. You don't have to specify again and again the type of that thing. We have some examples. There are like, we might have like other.
Yeah, there's some time arithmetic that you can do, subtraction and addition, and
all the utilities that you will expect from a type package. But one, it supports
and you can only have a duration for 200 years. Anything longer and you have to start playing around.
Let's see some, there are some fun implementation in time. One of it is for example, the ticker. Ticker, what is it? Ticker is a structure, okay, that implements, has an attribute C, capital C, that's a channel of time. If you notice, this declaration has this arrow over there. That means that the channel can be only read. Okay, so usually the channel by default are bidirectional, but if you specify this, then you can assign only, you can only read from that channel. You cannot send to it.
Someone else, of course, has to have the send end of the channel, or it doesn't work.
And let's see inside new ticker how they do it. It will panic if the duration is less than 0 because it's an int 64. I wonder why they didn't put an unsigned in. Oh, because you want to have a negative duration.
Yeah.
Okay. And then you create a channel of time with only one value. You create a ticker, and an attribute R. Now you guys wonder why we didn't see the R in the documentation. Because of the capitals. Okay, it's like
it is unexported.
It doesn't get exported, so it's like a private attribute. So what is creating here? Here is using nano This is an internal function, right? Of sleep, of the timer function, and you're it's setting up and creating it's setting up an internal timer, and it will start before it returns. So let's see inside the. What we'll do is.
So anyway, I'm not sure he ever explained what a ticker does. It sends a time to a channel every X nanoseconds. So if so you can range over that channel, and you'd end up, and your loop would end up running, you know, every second or whatever you set it to. One of the features of it is it's actually a buffered channel, see? But it's only buffered with one, so if you miss a tick, you can still pick it up. So if your loop takes over a second to run, you can, it will pick up the next one immediately, but if it then misses two, one of them will be dropped and you will lose it.
Which one will be dropped? Will it be the most recent one, or?
Yeah, the most recent
Okay.
one will be dropped.
The most recent one's dropped?
Yeah,
Okay,
so
cool.
so you'll get a time from a second after you started, but the second, third, whatever
Sure.
will be dropped.
Okay.
Because the channel is full, right?
Right.
That's
Okay, so nothing else
Right.
can get
It is
put
it
into it.
is a full
so
channel, and
Okay, that makes
it uses a select statement in
Mhm.
order to say send it if you can, but if you can't,
Yeah.
ignore it.
Sure.
so where I want to go to see the code of the ticker. Recall. So this is
You're going to eventually run into a stop, because that start timer, I believe, is implemented in the runtime C code, because it uses the scheduler to avoid, you know, starting another go routine and everything else. Time is one of those packages that talks to runtime in ways that you really can't. I believe it uses assembly to call internal methods.
Okay.
Now then, one thing that sort of confuses people.
So you
Time dot millisecond times 500 will work, because 500 is a numeric literal.
Mhm.
However, if 500 was, say, an integer, it would fail because you're trying to multiply a duration
Yeah.
times an integer.
For which either you do the dot C at the end of the new ticker, or you create, or you do
Right.
time dot tick. Because time dot tick is a shortcut for a new ticker with this.
Right. So just do dot C or, yeah,
That's
cool. Time dot tick just starts a ticker and returns C. So you can't stop the ticker, but
Mhm.
if you're going to run it forever, doesn't really matter.
Version C?
yeah. C is the
Yes.
channel that the ticker is pushing.
Got it.
this like when we were exploring the.
Right.
So this, as you guys expected, would be. What is it? Ticker example. Okay, another trick. Here. So this is. See, with T, it will say T declared and not used, but you can use underscore to just ignore it. This will run forever.
And what, like, and the reason to use this instead of just sleeping for a second would be because it tries to, the stuff you explained about it tries to even it out a little bit. And
Well,
It's-
it'll always run every 500 milliseconds. You know, with sleep, you have the time it takes to print
right.
being added on. Here, it will actually run every 500 milliseconds. It will start.
That's clear.
I mean, assuming it takes less than 500 milliseconds to print.
And
which
also,
is a fair assumption.
you can create the ticker and just send it over a channel, and the routine on the other side will just loop over it. Okay, like as you want to distribute times around. And this is tick what we're using. And notice like the return type is a read-only channel with type time. So you can pass around channels also and create them. It feels simple, no? Like the syntax and the language feels like, but I don't know. It's something like if you think back to C, it would be like this would be or in C++, it would be like, or in Java, like Mickey loves Java. Where are we? Yeah, these were any other interesting thing from time
There's the
after.
There's a formatting and parsing, which is nice, which they did instead of going the usual printf formatters, they actually have a format where 2006 is the year.
Go down a little more. Or
There is an
There's
example,
some
right?
Yeah, so
examples.
these are
Yes.
these are the example for constants. So ANSI C is man will always be the day, and the short day. Jan will always be the math. Underscore 2 or 02 would be the one, etc., etc. I find it somewhat confusing because they choose, in some cases, numbers that can be either an hour or a month, or you see like the minutes are 04. But 04 can be a month or an hour or.
By the way, it goes 1, 2, 3, 4, 5, 6. So January is 1, the day is 2, the hour is 3, although it's 3 p.m. So if you put in 15, it will use a 24-hour clock. If you put in 3, it'll use 12-hour clock. It's got 4 for minute, 5 for second, and it's the year 2006. And I believe it uses GMT -7, which is MST.
MST is
Microsoft
Mountain
Mountain
Standard
Standard Time.
Mountain, yeah.
yeah.
So,
Not
so
Microsoft.
how does it figure out that you didn't mean, oh, because it's a 3, 4, if it's a 3, it's always the hour.
Exactly. If it's a 3, it's always the hour or 15.
Another annoyance that there is there, if you have strings which the time is embedded, it tries to parse the whole thing. So if you have 04, which should be something else, and it will always convert it to time. So there's some advantages to the STRF time, you know. And if you really want an STRF time, you can grab the package I wrote someday out of frustration.
I mean, you have a package?
Yeah, I have an STRF time package. If you go to godoc.org, is it godoc.org? Yeah. Look for STRF time. STRF time.
Okay, this is a site that runs GoDocs
STRF time.
for any package on the internet. So if you put in any package, it will download the package and then show you.
Yeah. So this is the usual STRF time that if you do C or Python, and then you can embed things inside strings.
This is nice. Let's post it on the package. And let's see your bugs.
Yeah, there is a note there at the top. One thing is different. %C.
Oh, nice.
What is
guys,
different?
You guys notice the package itself will create the documentation out of it.
Yes.
Yeah, like you create a map of string, regex, parse it and switch. Nice.
Yeah.
The package is string at time.
Yes.
How do we use the one from the time package?
So
format.
there is a parse, and then the format that you give it, or not. There is a format. Yeah, time.format.
Package instead of source.
So look for formats. Yeah, this one. Yeah, so you give it the layout string and then.
So I have to put import the package time.
Yeah.
We say now,
Yeah.
and then here format.
Yes.
And now is time. We want
You can do
NCC.
Yeah.
And then is format printf.
Okay.
That's a
Probably
string,
print
right?
line would be
Yeah,
better.
print line.
And then go run. Well, if I want to specify my own format, that's what
Yes.
it gets confused most of the
Yeah,
time.
so you can put like 2006, it will be the year.
2006.
Dash.
Then if I say just 04,
04 is the day, I think.
Minute. 04 is the minute.
Yeah.
So the day is Monday.
Yeah. Oh no, there's the day of the month. I never remember which one is that.
Day of the month is 2.
Yeah, so 02.
so it's year, day of the month. What if I want to say like Jan? Here I have to put Jan, right?
Yes.
And if January and then 01 will be the day.
No, 02 would be the day.
01 will be the month.
Okay, 01 is the month, 02 is the day, 03 is
Hour.
the hour, while if it's 15 is the PM.
Yes.
Right.
Ah. And it's only for the 3, right? Read 3 or 15.
Right.
Then 4 is the minute, 5 is the second, right? Minute,
Yep.
second, 6, and we can go like that.
6 is the year again.
Oh,
But this time.
Okay. 2006 would print, 2013, while 06 would print 13.
so or 06 or 2006
Yes.
to differentiate the thing. And if I
Exactly.
want to say the time zone, MST,
MST, yeah.
Or minus 0770, minus 0700.
Right.
nice. That's the truth. Okay, well, once you know, it's actually a smart way to do it, but you have to
Well,
know it.
I think it's
Yeah.
easy to read, because if you're reading it, then the example is clear, but terrible to write.
Yeah.
Because it's hard to
Exactly.
remember when you're writing, like, 4 is which one? What?
Yeah, my main problem was with embedded. I had strings that had embedded time in them, and it also formatted stuff that shouldn't have been formatted because there's no escaping or something.
And it does it, did your package compile a little function that does it?
Yeah,
Because this one does it, you must do it on at one time, so if you're doing it a million times, it can't be super fast.
Let's.
No, mine is just doing a conversion from. It basically does a conversion from the STRF time format to the Go format, and then runs
Oh,
time
really?
format of it. Yeah, that's all it does.
There's no way to compile a format, though. It does it each time the functions run.
what we can do here is
But couldn't you make another interface where you would sort of just compile, like you could make your package sort of compile it, deform it once, and then apply it?
Oh, yeah. So I can just have a function, but again, inside the string there's no escaping. So I need to do some quick stuff.
So I installed Mickey's
Yeah.
package.
From GitHub. Oh yeah, I pushed it. I forgot.
Is that sure?
No, I pushed
It's
the
up to
Bitbucket
date, right?
and GitHub all together. So.
And now we can import it.
Bitbucket, no, github.com dash. github.com.
The background.
Yes.
Okay. Time. And we want to do the
Format.
same thing.
Yeah, so it's format.
Format.
Yes. Now you need the format and the time. So
Time, but now,
first is the format and then the time.
okay. So to have the same one above would be percent year, no?
Yeah, percent year and percent. And
Capital M? Not this.
no, and the capital is a minute. This is a minute.
Okay.
No, this is not.
This is exactly why you want to use the Go version as opposed to.
Yeah. So it's not capital M even. That's something else.
And remember there was
No.
like
Never remember that.
percent day, percent. No, this is the month, percent, then the day, then the hour, the minute.
Yeah, abbreviated month. You need percent
one
B.
of those is month, one of those is
Yeah,
minute.
the first time is
B, the second is M.
Yeah.
If I want the numeric
Yeah,
version of the
day, hour,
month,
minute. And minute is in capital M.
then I want minute, and then percent S. And then
Capital S again.
how you do the time zone? Alright, but like, let's see.
Percent capital Z.
Capital H.
Only.
Okay. But yeah, so you guys have
Good, you found the bug. Nice.
maybe it's from the old GitHub.
No, no,
Like
it's
it's not up to date. Okay. Nice time format is always something.
Yeah.
One. I think I had somewhere like one tool that will convert a numeric value to a human readable value. Say 10 seconds ago, 5 minutes ago, based on the thing. What else we have on time? I want to show the format equal this one after. Where is it?
There's another cool function called time.since.
Yeah,
You
the since-
give it another. You give it a time, and it will subtract it from time.now and return the duration.
The
So-
delta of the two functions, right?
Right. So you could do time.since, and it might return 3 hours
So
since you last. Yeah.
We didn't introduce explicitly select, but I want to talk about this after function. This also returns a channel time, and it will basically send you only once a message on that channel that amount of time has elapsed. And this is useful for example, timeouts. So you're sending a request to a server, and you want to say either the routine answer me with a value, or it will consume from this channel after this amount of time. Let me re-say that. So we have two channels here, okay? C and the channel that time after returns. The select basically will loop and will try to fetch from each of the channel.
But
until
it's more
one of the
efficient than
channels.
looping.
It's more efficient
Yes.
than
It
looping.
doesn't actually loop.
What? It has to.
Yes. What?
It has to loop, like it has to check once. Or no, I think
No, I
it
mean,
will just
it is the
signal,
schedule,
no?
yeah.
It will just signal it over
Right.
8. Yeah, that's interesting. And then, yeah, the first one that returns, it will, and the other channel, unless,
Is that the canonical way to make do a timeout?
yes,
Yes. Although, if you're doing this a bunch of times, it makes more sense to use a time dot timer, which is, time dot after is like time dot tick, where it's a convenience function and doesn't allow you to stop it. So if you were doing it over and over again, you might use a time dot timer and then stop it at the end, whether it fired or not.
because this will create a new channel each time.
But then if you, after you handle it, if the handle returns and you sort of exit the select loop, that won't kill the timer will still run.
The timer will still fire at some point, and
Then you will write to nothing because this...
exactly,
When it's
there'll be
done.
no one to write to because you probably forgot about the channel by then.
What
And
is the
also-
other one called?
What?
The other one called? You said we should use instead? Time the timer?
Yeah, timer.
And so that's like, if we want to pass this like outside the select loop, right?
Right, you would build it outside the select loop, you would do the select loop, and then you would stop it.
And then keep it running or what?
Or you could keep it running and then you might loop and use one timer so that after so that after 5 minutes of you working, you finally give up.
So we have to create something here.
Handle takes an M, which is a time.
We're gonna time
Hey, seriously, I need to learn how you do that.
what?
Add the
It's
imports.
control dot control P. You can delete or add. I just
Nice. Control dot?
control P as package.
So
Control or I think is
hold
or
control and type dot P. Or something
hold
like that.
control type dot control hold control type P.
It's not control,
Okay.
it's the super key. I'm not sure what that is on it.
Yeah, one of the two. I don't remember. And then here we
I'm gonna
are
try that.
gonna.
That's really cool. I didn't know about that either.
Yeah. I don't think I've got Go Sublime on here. I think it's only on my desktop. I'll try it when I get home.
Then
Handle has to take a time though, because you're passing a time in your thing. Yeah.
Alright, I'm passing. Okay, this is what I wanted to do. I want to create a channel. Okay, this function will signal inside the channel after a while. Handle is just handle.
You may not want to sleep 50 seconds, maybe 2.
And this I want to sleep for, if it doesn't complete in 500 milliseconds, while here is 2 seconds. Okay. Now notice this is valid because the way around. Let's see. Format I have it case. Okay, right? Like Here I'm declaring a function literal called handle.
This is not no. Oh, right.
Okay,
Not
I start the select. I read from the channel.
But you don't need to call handle first. First you call handle and then you start the selector. Otherwise you're gonna wait for the.
Yep.
Launch the coroutine. Okay. This will block. This will block. The coroutine will start. It will go inside the sleep. It will block here. The main will restart and do. Wait, this is not the same example. Sample is select time. M declare are not used. There.
That's not a printf statement. But whatever.
Fabrizio, we have 5 minutes.
Oh, already?
Yeah.
Yeah, that was fun. Okay. So it's timing out, right? Because this one is 500 milliseconds and this one is 2 seconds. While if we one, 2, and we'll return. Okay. Now we can, we didn't explicitly talk about the select, but let's say there is another statement that's default that you can, this will execute here. Okay, so it will, the first one is not, the second one is not, I can execute this statement. And it will return.
Default will run if the channels are not ready. However, watch out if you put it in a for loop or something because it doesn't yield. So what you would end up happening is it would just loop forever. It's the equivalent of an empty for loop.
Say that again, sorry, Steve.
If you were to put that into a for loop, although actually since there's the timeout, it may work. I don't know because it does some weird stuff in runtime. But the other one, I mean, if you weren't using time, what would happen is it would continually check over and over again without yielding to the scheduler. So another Go routine wouldn't be able to run and fill the channels. So it would just keep running forever.
Okay. So one use case of the default is when you want to check immediately. Like if there is nothing in the channel, you just go out.
Do you mean to type S? You said break S?
Yeah, because break, you can set
But
a
what is
label.
the S? Oh, the label? That's a label?
You can set a label in the break statement.
But you don't have label S.
I know.
Oh.
And it's very
The
simple.
magic label S, what?
No,
There has to be a label.
something like this, right? I don't know if you can. I think you can break if you have.
If you have 4,
If you have 2 4s, right? It was.
Yeah, you can put the
Right,
label and do that.
Okay, well, we're gonna
Or just
You
put
can
a go to
experience-
and go.
experience next time. I think
Okay.
this is pretty much.
There are rules on how you can use labels so that you can't do many things that may go to evil.
One last thing that we didn't really see is how to if I have more than the one processor, no, and I want to use more than one thread, you can set the number of threads that will then consume the Go routine. So you can set that with runtime.
Go will automatically check the environment variables for Go max procs, which is all in capital letters, but you can also set it manually.
So one way is if you pass 0 to Go max procs, you can see what is the default value of it. Okay, will not set it, will just retrieve it. And don't rely too much on the Go max proc because it's gonna go away in the future. It's just a temporary as long as the new scheduler gets improved. And then runtime.num CPU, it tells you how many CPU you have, so you can set
Stuff like for blocking forever, hopefully one day they'll fix. I mean, it's considered sort of a bug, not desired behavior.
Is it max procs go? And I have 8 unit power. So if I'm yeah, I can spawn this and I will have like I think at this point I will have to do this. I will have to do runtime dot go map procs and here I will set max parallelism. Okay, and this will use all the cores and do all the magic of the schedule.
There is an overhead for using more than one thread. There's some scheduling.
But
Yeah, your program may run slower if you up Go max procs. In fact, it's likely.
I tried it on my DNS server and it was fine. At least on my laptop, then with 4 CPUs, I was getting sort of 3.5 times faster than on one. And that's the thing that makes a gazillion small Go routines.
Yes.
So at least sometimes it works well.
I found it worked very well for when I was hashing many files.
Right.
You know, to split it up.
Yeah, if you're IO bound, then
We have some. You can do a control.control-R to run it. Not on mine. I think I have some customization of it. That is what. Okay, well, I think the time is out, but we covered all of what was the plan more or less. We saw select. We don't have the time for the exercise now, but for sure you have plenty of material to exercise
what was the
at home.
exercise? What was the exercise?
I was thinking to do like do a map reduce using Go routines and weight groups and channels. You spawn one process will just create 1,000 files with inside the file one number, and then you have to reduce map reduce. Like each Go routine will open one file. My idea would be you have one routine that will walk across the file system and put the path of the file inside a channel. Then you have another Go routine that reads from the channel, and from each file will spawn a new Go routine. That the Go routine will open the file, read the input, get back and then you have another channel that will collect all the values, and then you will have a reduce function. And you can do that with multiple channels. Like you can get fancy as much as you want. Okay, well, let's see. Next time we start with something more, even more practical. Like we have a foundation of how to use streams. We have a foundation of how to use Go routines and like trading. We're gonna be able to start using the net package. So communicating across computer, we're gonna be able to understand how to use the HTTP package. That is one of the things that most people are interested in. We're gonna maybe able to see some of the encoding libraries like JSON, XML, and GOB. And I think at that point, like the amount of program that we can start tackling gets wider and wider. And I also want, like, if you guys are committing to go, Miki and Steven are committers to the main Go
No, not the
package. Like
I contributed
Commit-
some patches, but not
sends patches to it, like, but still, like.
I cannot
See-
actually add stuff without, approval.
Can anyone who is say now at Google?
What?
Can
Yes.
in here?
You can just send in a patch and.
No, I mean, are there anyone who actually commits that are not working at Google?
Yes,
Yeah.
I believe so.
Yeah, I think
Yeah,
some
it's open
companies-
source.
Yeah, I think
Yeah.
at least Gustavo is in Canonical, so.
Gustavo
I mean,
Neumeyer.
Yeah.
Wasn't the entire Windows port done by contributors?
I think so, right?
Pretty much. I mean, the main Go people are not
Yeah.
Windows people.
Right.
But that does not necessarily mean that they're committers. Okay, committer just means that they are people who are allowed to make a final say and actually put it in the repo.
Okay.
Anyone can post
Oh, okay.
to
1 second, let
the
me-
code review system and then ask for people to look at it, including
Okay.
committers.
So something like that.
Let me
pull
guys
request.
wrap
Yeah,
up
exactly.
the hangout. Thank you for who's following online, and we'll put the new information on the next meetup online. As always, like, share if you like it, if you hate it, if you don't understand my accent, anything that anything that can make can grow the meetup. As I think Go is one of those languages that can have like a bright future in the next year. So I think it's something that as many people as possible can understand and like start practicing is the better. And that's it for this episode. See you next time.
See you next time.